oxide nanowires. I'm buying Dr. Ryan Young, University of Pennsylvania, and you can level drugs on the nanowires, and then you can administer it. And this is, there are, I think nowadays, more than 100 papers you can find, not only ours, but others. So there are special techniques that copper nanowire, we have silver nanowires, different types. We are using titanium nanowires, and it's 20 to 50 nanometer in size, and then it's kind of possible. Yes.
You have used that Nanowired containing. How do you determine that they are fully cells? How do you know?
That's a very good point. But at the moment, we are working on the pharmacology. That's why I said that what we have measured, one way is the enhancement of IGF level of plasma, and that is much more effective when we nanowire. So it is something doing in this system, but we are not doing at the moment. So finding is what I mean, or controversy.
Second point is due to the level of pH between more.
IGF
IGF versus less. Does not indicate that you have less in the brain than in the blood. Because in the peripheral blood, then the brain will open up in the brain is less.
Yeah, but spinal cord trauma, if you measure at different segments, you can see a different profile of increase. So I don't believe that it's a simple up and down relation, because whatever you do in any clinical conditions, if you look immunohistochemistry or cytochemistry or genes, I mean 200 genes are upregulated, 400 genes are downregulated. What does it mean? Practically none. Okay? We cannot have this cause and effect relationship. But these are the method that something is happening biologically that is working much more better than the when we have different nanowire. I'm not telling the mechanisms. I'm only providing the facts. And the conclusion is probably nanowire is much more effective.
Last question. What is the molecular weight of the molecular weight of the Nanowired?
My friend who is a biochemist, Dr. Ryan Tina, he might be knowing it. You can find titanium molecular weight is simple chemistry.
Really interesting. I've been trying to follow some of the work. One of the things that I was curious about is when they're coating the nanowires versus putting it on the other way. Do you think it's actually the fact that it's disaggregated and it's not a billion molecules or 100 million molecules in a big clump, and it's actually spread out so you're getting much better penetration? Do you think this is a
That is still several $1 million question. And yeah, and the point is that that's why we are comparing. First, I have no answer.
yeah.
Okay, the first thing. The second thing is that, I mean, it is very difficult to see how much the amount is released and how much amount is reached to different areas.
Yeah.
And for that, we are using another way of like PLGA level, you know. That my colleague in Italy has more control over this. So this area is still, I mean, nobody has shown that how much actually after nano delivery the drug reaches to the target. Yeah. So.
But let me just follow up with this, because one of the things, as we all know, growth hormone actually breaks down very, very quickly. Do you think the nanowire is actually stabilizing the structure so the length of time that the drug is actually stable is over a longer period of time than the other types of applications?
We believe that this is the basic idea why nanowire delivery of drugs can do better, because they control the drug and also prevent from catabolism inside the body. That could be one of the possibilities. But I do not have any hard fact to share.
So, if you gave, you probably must have done, if you gave nanoparticle IGF-1, the
Yes.
topical application is now
Yes.
into the site.
Yes.
What sort of effect would you expect to see in the
Okay, in 1997, we have given only IGF-1 topically over the spinal cord in the same model and saw neuroprotection within 5 hours period. And then we also added BDNF over that, and the combination was much more effective. But so far we have not added Nanowired, IGF-1 or BDNF so far. So IGF-1 alone is neuroprotective up to 5 hours period. At that time, this investigation was complete.
Now, if you give it in gel form, it will be released, and then you can measure the level of IGF.
That's right.
How
That's
it's
a good idea. Yes, yes.
Effect you see, you gave also stem cells.
I cannot say, yeah, we are doing, but I cannot tell you the results, yes.
Okay, so how do you go, if you give stem cells, how do you go, they're differentiated
Yeah.
into what? And if they're differentiated into neurons, how long they survive?
In this case, we have not given stem cells.
You haven't done that yet. So that would be interesting to
Yeah, sure. Yeah. We have tried some experiments with nanowired stem cells. And I can only disclose to you here that nanowired stem cells are better than not, and only mesenchymal stem cells.
Yeah, and as you know, ICF-1
Yeah.
promotes brain development
Yeah.
and mind development.
Okay.
So I think that is very important.
Yeah.
Because
So
we
that's
all
why.
want to have axons preserved
Yeah.
and also myelin sheath remain intact.
Sure. Yeah. That's right. Yeah. Yes, sir.
What's the ultimate disposition of the titanium oxide nanowire?
No idea. Not only titanium nano, but any nano,
Yeah,
like
yeah.
iron, even
I
carbon.
mean, you're instilling this right directly intrathecally onto the spinal cord, correct?
Yes.
And so do you think that the titanium oxide nanoparticles migrate, or do they precipitate out and stay local?
It's difficult to tell scientifically, but it can be a wild guess that in the period of 24 or 48 hours, they might stay low.
Yeah.
You measure them in the urine and you detect them.
Not yet. We do not have yet technique to study different types of nanoparticles in the brain of life.
All right, thank you very much.